In this video, we're going to take a look at section 7.6 on graphing quadratic functions that are in standard form, as opposed to the last section where they were in vertex form. All right, so let's take a look at what we mean by standard form. The standard form for a quadratic function is given by the formula f of x equals ax squared plus bx plus c. So we have seen this expression previously in this course. It is the quadratic expression. We learned to factor things like this. We learned to solve equations with things like this. So it's ax squared plus bx plus c. That is your standard way of writing something quadratic. And in this case, we're setting it equal to f of x. We're setting it equal to a second variable. And so it becomes a graphing type of problem when you do that. These graphs will also be parabolas. They're just like quadratic functions in vertex form. They have the same kind of graph. They're parabolas, which means they have the same features. They have vertex and they have an axis of symmetry. And we're going to be doing a little bit more in this section, going beyond just finding those two things. To find the vertex when it's in standard form is going to be a little bit more work. When it was in vertex form, we could just read the vertex directly off the equation. When it's in standard form, we have to compute the vertex. We have to use a formula and calculate it. The vertex for a quadratic function can be found using the formula x equals negative b over 2a. Please note the negative sign here in front of that fraction. It kind of blends in with the fraction bar, but there is a negative sign in front of that, and that's important to make sure we get the right answer. That gives you the x-coordinate of your vertex when it's in standard form. To find the y-coordinate of the vertex, you take whatever you get for x and you plug it into the original equation. So to find the y-coordinate of the vertex, plug this result into the original function, and that'll tell you what y is equal to. And so that's how you find the vertex. The line of symmetry is the same as it was in the previous section. It's going to be x equals the x-coordinate of the vertex. And so we'll still find that information in the same way. And maximum and minimum kind of mean the same thing. So, as they did in the previous section, right? That's the highest or the lowest point on the graph, which is the vertex. So these first couple of problems are going to be repeats of what we did in the previous section, except now the function is in standard form, so finding the vertex is going to be a little bit more work. So for the quadratic function, f of x equals negative x squared plus 2x plus 1. Find the vertex. We won't be able to read it off the equation this time. We will have to calculate it using the formula we just had on the screen. Find the line of symmetry. That's the same as it was in the last section. Once you have the vertex, you just do the same thing here. And then the maximum or minimum value. So once you have the vertex and you're graphing it, you can figure that out the same way we did in the last section as well. All right, so let's start by finding the vertex, because that's going to take us a little bit of work here. So the vertex, to find the x-coordinate of the vertex, we use the formula negative b over 2a. b in this case is equal to 2. A in this case is equal to negative 1. So we'll plug those numbers into this formula. So we'll have negative b, which is 2, divided by 2 times a, which is negative 1. So this will give me negative 2 over negative 2, which is going to be positive 1. So that's the x-coordinate of the vertex, positive 1. To find the y-coordinate, we will take x equals 1 and plug it into this equation. So we're going to have f of 1 equals negative 1 squared plus 2 times 1 plus 1. And so we have to simplify that. We will get negative 1 plus 2 plus 1. The negative 1 cancels out with the positive 1, so we're just going to get 2. So the y-coordinate of the vertex will be 2. And so that's how you find the vertex when it's in standard form. This one was pretty easygoing. Other ones are going to be a little bit more complicated, especially if you don't get such a nice number for the x-coordinate. This could easily work out to be a fraction, and we will see, hopefully, at least one example of that happening. All right, so we get 1 comma 2, which will be right here. Now, I don't know if that's a maximum or a minimum yet until I know whether the parabola is right side up or upside down. You actually can know this already. We talked about this in the last section briefly. When a is negative, it's going to open down. It's going to be an upside down parabola. So this actually will be a maximum. But that'll also be borne out once we plot some points. You'll see that the points are going to be below the vertex, so it's going to be an upside down parabola. All right, Before we get to plotting points, let's do the next thing we're being asked to find here, which is the line of symmetry. So I don't know, it's weird. In the previous section, they were calling it axis of symmetry. In this section, they're calling it line of symmetry. I apologize for the change in terminology, but it's referring to the same thing. And you get the answer in the same way. It's going to be x equals the x-coordinate of the vertex, which is 1 in this case. So that's it. That's the line of symmetry. That's the axis of symmetry. It's this vertical line right here that passes through the vertex. Let's see if I can draw a vertical line through that. All right, so this is our axis of symmetry. That can help us with graphing. Just like we had to do in the last section, this is not enough information to know what the parabola looks like. We need a couple of more points to help us figure it out. And so we need to plot a few points by choosing a value for x, plugging it into the equation, letting the equation tell us the value for y. Stay close to the vertex. In this case, 0 is a really great choice. It's very close to the vertex, and it's just easy for plugging in and computing. So I'm going to plug in 0 for x. I'll do that up here. I'll get f of 0 equals negative 0 squared plus 2 times 0 plus 1. That's going to be 0 plus 0 plus 1, which will be 1. And so we'll get 1 for y. And so that'll be this point right here. Using the symmetry, that's 1 to the left of the axis of symmetry. So if I go 1 to the right of the axis of symmetry, I'll get a mirror image point the same distance away. And so 1 to the right would give me this point right here at 2, 1. Right. So what I mean by that is if I go the same distance away on the opposite side of the line of symmetry, I'll get the same y coordinate. Right. So same distance away would be 1 to the right. I'll get y equals 1 there as well. So that gives me this point here. So that's going to give me 2, 1. Now Math Excel, that's going to be plenty of information for it to graph the parabola for you. You plot the vertex first, you plot this one point, and it does the rest of it for you. But on paper, it might be helpful to have at least one more set of points to work with here. So let's pick another value for x. Let's pick 3. We already have 2 here, so let's pick 3. And we'll plug that in. We'll do it up here as well. Well, no, I can't because I had to hide my tool bar, which lets me switch from writing to erasing because I had to make this window a little bit bigger to hold all the information. So I can't. It would be difficult for me to erase, is what I'm trying to say. So let me just plug in 3 down here, right? So I have f of 3 equals negative 3 squared plus 2 times 3 plus 1. All right, and so that's going to give me, when I square this, now I know the rule is whenever you square a number, it comes out positive. But this negative sign is not getting squared. Right? Just the 3 is getting squared. So 3 squared does work out to be positive 9, but then that negative sign will just copy down in front of it. So we get negative 9 there, plus 6 plus 1, which is going to be negative 2. And so we'll have 3 comma negative 2, which will be this point right here. Using the symmetry, that's 2 to the right of the axis of symmetry. So I will go 2 to the left and get the same y coordinate, which will be a negative 2 again. So that's going to be negative 1, negative 2. And with those 5 points, you get a pretty good sense of the parabola. So let's go ahead and draw this. Again, it does open down like I said it would. All right, and so it's going to look something like that, hopefully passing through the points that you plot. And so the vertex is at the top of the graph, right? It's at the top, which makes this a maximum. And the maximum y value here, let's try that again. So the maximum y value here is going to be y equals the y coordinate of the vertex, which is 2. And it's a maximum because it's at the top of the graph. It goes no higher than that. So that is the largest value that I can get for y, which is why it's a maximum. There is no minimum here because the graph goes down forever. It goes to negative infinity. So it doesn't bottom out anywhere, which means there is no minimum. All right. So let's take a look at another example of a quadratic function in standard form. All right. So same thing here. We're going to find the vertex. It's in standard form. And so we'll have to use this formula, negative b over 2a. And this one looks like it will work out to be a fraction. I was hoping I'd have one of these on my lecture. Hopefully you don't have too many of these on the homework because they are a little bit more work. B is equal to 2 and a is equal to 2. So we're going to plug those two numbers in here. We'll have negative 2 on top, and then 2 times 2 on the bottom. That's going to give me negative 2 over 4, which unfortunately is negative 1/2. So while I'm happy to make sure I have an example of this in my lecture, I'm really not happy to have to deal with this. It's a fraction. I really don't want to, but that's the answer that I get. So the x-coordinate is negative 1/2. Hopefully on Math Excel, it lets you do half coordinates. I think it must in this case, if you have to plot the vertex, because it's a fraction. So, and we're going to have to plug that in to the function to find the y-coordinate. So getting an x-coordinate that's a fraction isn't the big deal. The big deal is you have to take that fraction and plug it back into the equation, and that's where it becomes a real pain, right? So we're going to have to plug negative 1/2 back into the equation. So we get 2 times negative 1/2 squared plus 2 times negative 1/2 plus 6. And we're going to have to try to simplify this. And so this will become 2 times 1/4 plus 2 times negative 1/2 plus 6. So when you square a fraction, you just square the top and you square the bottom. So 1 squared gives me 1, 2 squared gives me 4. And because I'm squaring this number, it comes out positive. So it's positive 1/4. Think of this 2 as being 2 over 1. So the 2 on top cancels out with the 4 on the bottom, so I'll get 1/2 from that. Do the same thing here. Think of this as 2 over 1. The 2's cancel out, and we get negative 1 divided by 1, which will just be negative 1, plus 6. And so that's going to give me 1/2 plus 5, right? Because negative 1 plus 6 will be positive 5. Think of this as a fraction. We have to get a common denominator. The common denominator will be 2. So I multiply 2 to the top and bottom here. So I get 1/2 plus 10 halves, which will be 11 halves. And so that will be my y-coordinate for my vertex. All right, so that took up all of my screen just figuring that out. The line of symmetry is just going to be x equals the x-coordinate of the vertex, just like always. All right, so get the same thing there. And so we'll plot this point, negative 1/2, comma 11 halves, which as a decimal, it might be helpful to think of it as a decimal. That's 5.5. So I want to go halfway between 5 and 6. So negative 1/2, and then halfway between 5 and 6 would be like right here. So it's halfway between 0 and negative 1, halfway between 5 and 6. That's the vertex. It actually opens up from there because A is positive, so it's going to be a right side up parabola. But we will discover that as we plot some points, which is the next thing that we need to do. So I will set up a chart here like we've been doing on the previous problems. We want to stay close to the vertex. 0 is pretty darn close, so I will pick 0 for x. And this one we can really just work out mentally. We don't need to write this out like I did in the last example, because when you plug in 0 for x here and here, those terms just go away, right? 2 times 0 is going to be 0. 0 squared is 0, right? So this all just zeroes out, and so you just get 6 as the result there. So we'll have 0, comma 6, which is going to be really close to the vertex right there. Using the symmetry, if we go the same distance away on the opposite side of the vertex, we get another point at y equals 6. So it'll be at negative 1, comma 6. Right? So negative 1, comma 6. That's going half to the left of the vertex. We get that point at at 6. Sorry, I'm totally butchering what I'm trying to say here. I apologize. Hopefully, just looking at it makes more sense than what I'm trying to explain. And that really gives us a good start to the parabola, but it'd be nice to have some guidance as we get a little bit further away from all of that. So I'm going to suggest let's plot another point. I'll pick x equals 1. That seems like an easy one to plug in. And so if you plug in 1 here for x, you'll get 1 squared, which will still just be 1. So this will be 2 times 1, which is 2. This will also be 2 times 1, which is 2. And then plus 6, adding all that up is going to give me 10. So we'll get 1 comma 10, which will be right here. And again, using the symmetry, if we go the same distance away on the opposite side of the vertex, that'll be at negative 2, we would also get y equals 10. So same distance away on the opposite side of the vertex, on the opposite side of the axis of symmetry, which I didn't bother drawing here because it's just too cluttered, and I just thought it would get too messy. All right, so that gives us a pretty good sense of the parabola there. All right, so we'll connect those points in a parabolic shape. Oh, that's probably the best one I've drawn so far. All right, so that's what the graph will look like. This time we have a minimum, right? The vertex is at the bottom of the parabola, and so that will be a minimum value. The minimum y value here is whatever the y coordinate of the vertex is, which is 11/2. So that's as low as this graph goes. It doesn't go any lower than 11/2. That's the minimum for this graph. It has no maximum because the graph will go up forever. So there's no top value, right? Because it'll just keep going. Whatever you try to set as the maximum, this graph is going to blow past it. So there's no maximum, but there is a minimum. There is a minimum value for which the graph will not go any lower. And that minimum value is 11/2 for y. All right, so that's all the graphing that I have in this lesson. The next topic is on x and y intercepts. To find the y-intercept, it's the same thing that we did before in Chapter 2. It was a long time ago, but to find the y-intercept in Chapter 2, the process we followed is what you see on the screen right now. You plug in 0 for x, and then you solve for y, and that gives you the y-intercept. It's the same thing that we did back in Chapter 2 for linear equations. And it's the same thing that we just did on this last problem, right? So we plugged in 0 for x here, and we got y equals 6. This is the y-intercept for this graph, right? So we found the y-intercept here. The y-intercept is pretty easy to find. Plugging in 0 for x is a pretty easy thing to do, and you get the answer pretty quickly. The x-intercepts, however, are going to be a little bit more of a challenge. You do the same thing that we did back in Chapter 2. You plug in 0 for y, and then you solve for x. It's the same exact steps that we had in Chapter 2. It's just that plugging in 0 for y, when you have this kind of equation, is going to give you 0 equals 2x squared plus 2x equals 6. And then solving that for x is solving a quadratic equation. And that's going to be a little bit more challenging. You might try to solve it by factoring. You might have to solve it using the quadratic formula. In this case, there are no x-intercepts, right? The graph doesn't even cross the x-axis. So trying to solve that equation actually would just give you imaginary solutions, which means the graph has no x-intercepts. So that's another thing you have to be on the lookout for, is that maybe the graph has 2 x-intercepts. Let's see if we had an example of that today. Like here, right? So this parabola crosses the x-axis twice. So this graph will have 2 x-intercepts. And so we should be able to find those by solving the equation. You plug in 0 here, and you solve that quadratic equation to find those x-intercepts. This one has none. So you have 0 x-intercepts here, right? So this has no x-intercepts. And it is possible, sorry, I didn't write very well. It is possible to have just 1 x-intercept if you have a parabola that looks like this. If I could draw it. Right, so if you have a parabola that looks something like this, the vertex being directly on the x-axis means you have 1 x-intercept. So it can run the gamut. You might have none, you might have 1, or you might have 2 x-intercepts. Depends on the situation. Right? So let's do some examples. Find the x and y-intercepts for this graph. Let's do the y-intercept first because it's just easier. Right? So the y-intercept, we'll plug in 0 for x. So we'll get 0 squared minus 6 times 0 plus 4. That's just going to be 0 minus 0 plus 4, which is going to be 4. So that's the y-intercept. The x-coordinate is 0, because that's what I plugged in for x. The y-coordinate is 4. So that's all there is to the y-intercept. The x-intercept, we'll have to plug in 0 for y. Right? The f of x, the function notation, is the y variable. So we just give it a different label, but that is the y variable here. So we're going to plug in 0 for y. So we're going to get 0 equals x squared minus 6x plus 4. And then to find the x-intercepts here, we have to solve that for x. I would highly recommend trying to solve it by factoring first, but this one won't factor, right? We have to find 2 numbers that multiply to 4 and add to negative 6. There aren't 2 numbers that we will be able to easily think of that multiply to 4 and add to 6. So this won't factor, which means we have to use the quadratic formula, which we just learned earlier in Chapter 7. It's negative b plus or minus the square root of b squared minus 4ac over 2a. A is equal to 1 in this case, b is negative 6, c is 4. Now if this works out to be imaginary, then our answer here will be that there are no x-intercepts. So as soon as if I get a negative inside my square root, I just quit. I just say, okay, well, it's going to be imaginary. I don't need to do any more work on this. There's no x-intercepts. If this comes out positive, then we have x-intercepts. They might not be very nice numbers, but they are what they are. So let's see what ends up happening in this case. So we're going to plug in negative 6 for b. So we'll have negative, the negative sign here, copies over here. And then b is negative 6 plus or minus the square root of negative 6 squared minus 4 times a, which is 1, times c, which is 4. The whole thing divided by 2 times a, which is 1. So we simplify this, we'll get x equals positive 6 plus or minus. I'm going to run out of room pretty fast here. So here's a way we can kind of save ourselves a couple of steps of writing. We can just kind of simplify this up here. So negative 6 squared will be positive 36 minus 4 times 1 times 4 will be 16. So we're going to get 36 minus 16, which will be 20. So we get the square root of 20 over 2. And so there are x-intercepts. This is not going to be imaginary. Even though it doesn't simplify really nicely, it's not imaginary. So we do have some x-intercepts here. So we need to simplify this by splitting it up. We'll write it as 4 times 5. Apply the square root to each of those separately. So we get 6 plus or minus 2 square root of 5 over 2. And just like we were doing earlier in chapter 7, we will reduce this fraction by dividing the 2 into each term separately. So we'll get 6 divided by 2, which is 3, plus or minus 2 square root of 5 divided by 2. The 2's will cancel out, and we'll just get square root of 5. Right. And so those will be my x-intercepts. There are 2 of them. One where I use the plus sign, one where I use the minus sign. So to type this into Math Excel, I'm pretty sure it wants you to type it in as ordered pairs. So you're going to have to split this up and write this as 3 plus square root of 5 and 3 minus square root of 5. Let me rewrite that last one there because it's the minus sign kind of blended in with the square root symbol. And to write these as ordered pairs, that's the x-coordinate that we found. The y-coordinate will be 0, right? Because we plugged in 0 for y over here. So that'll be the y-coordinate for that one, and that'll be the y-coordinate for this one as well. All right, so there are our 2 x-intercepts, and that's how you'll have to type it in to Math Excel. All right, so that was a tough one. Hopefully they're not all going to be quite that bad. Let's take a look at the next one. All right, so we have f of x equals 9x squared plus 6x plus 1. And we want to find the x and y intercepts here. Let's do the y-intercept again real quick because it's just easy to do. Get this one out of the way. So we're going to plug in 0. Oh, if I can write it out, it won't be too hard. Plug in 0 for x. We get 9 times 0 squared plus 6 times 0 plus 1. Again, all of these things just go to 0. And so we'll get 0 plus 0 plus 1, which will just be 1. So my y-intercept is 0, 1. So we're done with that. Now let's take a look at the x-intercept, or intercepts. There could be 1, there could be more than 1. Well, like we had in the last example, there was 2. So again, this is your y variable here, so we're going to set that equal to 0. So we'll have 0 equals 9x squared plus 6x plus 1. And then we need to solve this equation. It's a quadratic equation. You could use the quadratic formula, but this one actually can be factored. And so you could do the AC method. All right, so a times c is going to be 9 times 1, which is 9. B is equal to 6. So 2 numbers that multiply to 9, add to 6, would be 3 and 3. So we'll rewrite the middle term 6x as 3x plus 3x. The 1 copies down, the 9x squared copies down, and then we do factor by grouping. So we'll group the first 2 terms together, group the second 2 terms. Common factor in the first group is 3x. That's going to leave me with 3x plus 1. There is no common factor in the second group, but that's okay because it already matches the thing left over from the first group. And that's really the most critical thing, is that these 2 parentheses match each other. Since they match, I can factor them out. So I'll factor out the 3x plus 1. What I'll be left with is a 3x from the first group and a 1 from the second group. There's an invisible 1 here. So I'll have a 3x plus 1 left over when I factor that out. Right. So now, to solve this for x, we'll set each factor equal to 0, and we will get 3x plus 1 equals 0, and we'll get another 3x plus 1 equals 0. So obviously, we're going to get the same answer from both of these. Right? So we'll just do it one time instead of writing it out twice because it's the same answer in both cases. So we'll subtract 1 from both sides. We get 3x is equal to negative 1. Divide by 3, and we get x is equal to negative 1/3. So this time we have just one x-intercept. Let me rewrite that 3. I'm not real happy with it. All right, we get one x-intercept here. So to type that into Math Excel, the proper way to write it on paper even, is to put the x-coordinate first. So the x-coordinate's negative 1/3, comma, y-coordinate, which is 0, because we plugged in 0 for y. So this is one of the rare cases where there's just one x-intercept. That doesn't happen very often. Usually there's 2 or there's none. Only having 1 is pretty rare. All right, so I have a couple more examples, but these are kind of repeating the things we already did earlier in the video, so they're really here for you to try first. This is what I would do in my face-to-face class. I would have my students do this problem, and then I would provide them with help and with the answers after they've had a chance to try it. So you should try to do the same thing. Pause the video, give this problem a try, find the vertex, the line of symmetry, and the maximum or minimum value of the function. And while it's not on the screen, obviously the graph is here for a reason, so put the graph together as well. And then once you've tried to figure all that out, resume the video to see how on target you were with that. All right, so for the vertex, remember we have to use a formula here to calculate it because it's in standard form. So I have negative b over 2a is the formula for getting the vertex when it's written like this. b is equal to negative 6. A is equal to 1, so we'll plug those numbers in, and this one's actually fairly nice in how it works out. It's not a fraction this time. So we have the negative sign from the formula, and then b is negative 6. I'm sorry, my 6's and my b's look really similar, so whenever I'm plugging in 6 for b, I'm always paranoid about students not realizing I plugged a number in. And then a is equal to 1, so we'll have 2 times 1 on the bottom. The double negatives cancel each other out, so we'll get 6, positive 6 on top. 2 times 1, which is 2 on the bottom. 6 divided by 2 is 3. So the x-coordinate of the vertex is 3. To find the y-coordinate, we take this value for x and we plug it into the equation. So we'll have f of 3 equals 3 squared minus 6 times 3 minus 6. And so that's going to give me 9 minus 18 minus 6. Let's try writing that 6 again one more time. Which will be negative 9 minus 6, which will be negative 15. All right, so I'll get negative 15 for y. And that'll be my vertex. So 3 comma negative 15, which is going to be way down here. There's negative 15, and then 3 over from that would be this slightly thicker line right here. All right. So that's where the vertex is located. All right. The axis of symmetry, part B, the line of symmetry, will just be x equals 3. Right? It's just the x-coordinate of the vertex. That's how you get the line of symmetry, which is going to be this vertical line right here. This vertical line that passes through 3 on the x-axis, passes through the vertex as well. Right? The parabola has to be symmetric to that. And so let's plot some points. Right? So I'll go ahead and maybe make the chart up here. We'll pick a couple values for x. We'll try to stick close to the vertex. Because there's no extra numbers here for a, like when a is a bigger number than 1, numbers can get pretty big pretty quick. But since it's just a 1 here for a, I think we'll be safe choosing 0, which will be the y-intercept, right? So we'll go ahead and find the y-intercept here by plugging in 0 for x. And that's just an easy number to plug into the equation. So let's do that down here. We'll get f of 0 equals 0 squared minus 6 times 0 minus 6, which is just going to be negative 6. So 0 comma negative 6 would be right here. Using the symmetry, if we go, that's 3 to the left of the axis of symmetry. So if I go 3 to the right, I should get another point with the y-coordinate of negative 6. So 3 to the right would be at 6. So we'll get 6 comma negative 6 as our free point using the symmetry. Let's get one more point here just to really bring out that parabolic shape. I will choose 2. Let's pick 2 for x. We'll plug that in here. So we're going to have f of 2 equals 2 squared minus 6 times 2 minus 6. That's going to be 4 minus 12 minus 6, which is going to be negative 14. Right. And so we'll have 2 comma negative 14, which is going to be located right there, I believe. Let's see. No, I'm sorry, I'm off by 1. Right. It's just above the vertex, right? 2 comma negative 14. Using the symmetry, I'll go 1 to the right of the axis of symmetry, and I'll also have another point at negative 14 for y. Right. So the y-coordinate of that point will also need to be negative 14. So same distance away on the opposite side of the axis of symmetry, you'll have the same y-coordinate for that point as well. Right. So I don't know if I'm saying that the best way, but it's the mirror image point, right? So for every point that's over here, there has to be a mirror image point the same distance away on the other side of that line. And so with these 5 points, we have a pretty good sense of what the graph looks like. So let's connect them together in a parabolic shape, and it's going to go pretty vertical from there. Okay, I'm going to try that one more time. I don't know if I'll do it any better. Okay, not too bad. All right. And so this time, we have a minimum, right? So the parabola is right side up, which means the vertex is the bottom of the graph, which means we have a minimum point. So you'd want to pick minimum in this case. And the minimum value for the function is the y-coordinate of that vertex, which is negative 15. That's as low as the graph can go. So that is the minimum for the graph. This graph has no maximum because it goes up forever. All right, one more repeat of a problem here. This one, I think I have to do the quadratic formula again, it looks like. But find the x and y intercepts for this function. So I will ask that you again pause the video, try to find this information for yourself first, and then resume the video to see if you came up with the right answers. All right, so for the y-intercept, we're going to plug in 0 for x. So I have 5 times 0 squared minus 0 plus 5. Again, all that goes away when you plug in 0, and so you just get 5 as your y-intercept. So it'll be 0 comma 5. For the x-intercept, we have to plug in 0 for y. So this is my y-coordinate here. The f of x is my y. I'm going to plug in 0 for y, so I'll get 0 equals 5x squared minus x plus 5. You might consider trying to solve this by factoring first, but I can tell that's not going to work out, because if you consider the AC method, a times c would be 5 times 5, which is going to be 25. b is equal to negative 1. So for this to be factorable, I'd have to find 2 numbers that multiply to 25, but add to negative 1. And I can't think of 2 numbers that do that. So this will not factor, which means I will need to use the quadratic formula to solve it. So remember, the quadratic formula is negative b plus or minus the square root b squared minus 4ac over 2a. All right, a is equal to 5 in this case, b is equal to negative 1, c is equal to positive 5. So let's plug those numbers in. We'll have x equals negative, because that's in the formula, and then b is negative 1. Let's try that again. Negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is 5. Not 1 this time, it's 5. Times c, which is also 5. Over, the whole thing over 2 times a, which is 5. Sorry, I kind of wrote that funny, but we got there. All right, now this one, what's going to happen is we'll get positive 1, because the double negative makes that positive. And let's go ahead and simplify this a little bit here so it's less writing over here. Negative 1 squared will be positive 1 minus 4 times 5 times 5. That's going to be 25 times 4, which is 100. So we're going to get 1 minus 100, which is negative 99, over 2 times 5, which is 10. I mentioned this earlier in the examples that we did earlier. Having a negative in the square root means this answer is going to come out imaginary. And if the solution to this equation is imaginary, that means the graph will have no x-intercepts. So that would be our answer in this case. I don't have to go any further with this problem. I don't need to split up the 99 as 9 times 11, which is how you would have to do it if you were going to try to simplify the square root. We don't need to bother simplifying it because what we're interested in is not the solution to that equation. We're interested in what are the x-intercepts here. And because the answer works out to be imaginary, the graph will have no x-intercepts, so I'm not interested in simplifying that answer any further. I got the information I needed out of it. There are no x-intercepts for this particular graph. And so this is the answer that you would want to put in Math Excel. Should be one of your options. Option A is the x-intercepts are blank. Option B is there are no x-intercepts. So choose option B in this case. All right, so that concludes the video on section 7.6 on graphing quadratic functions in standard form.